In this podcast, we're going to talk about the mole. The mole is nothing more than a unit so that we can describe the amount of a microscopic substance on a macroscopic level. Before we get into the mole, we have to simplify atomic mass. The atomic mass, as you remember, is the average mass of all the different isotopes of the atoms out there for one particular element. For example, carbon has an atomic mass around 12.0107. Well, in Chemistry 1, we're just going to simplify them into their whole numbers. So carbon's atomic mass is 12, and we say AMU for atomic mass units. Oxygen is 16 AMU. Iron on the periodic table is 55.8 something. We're going to round that to 56 AMU. And chlorine is 35.45, which we're going to go ahead and round that back down to 35. Formula mass is when you take all the atomic masses of all the elements within a compound and add them together. For example, water has 2 hydrogens, each having an atomic mass of 1, and 1 oxygen having an atomic mass of 16. 2 times 1 plus 1 times 16 is 18 AMU. 1 molecule of water weighs 18 AMU. Manganese 3 carbonate has 2 manganese, each having an atomic mass of 55. It has 3 carbons, each having an atomic mass of 12, and 9 oxygens, each having an atomic mass of 16. If we add all those together, you get 290 AMU. So one compound of manganese 3 carbonate weighs 290 AMU, whereas one molecule of water weighs only 18 AMU. So before we get into the unit of the mole, let's talk about other units that we see in our everyday life. For example, if I say I have a pair of shoes, I have 2 shoes. If I say I have a dozen eggs, I have 12 eggs. If I say 4 score and 7 years ago, a score represents 20 years. A gross is a dozen, so that's 144. And if I say I have a ream of paper, I have 500 sheets of paper. A mole is nothing different than any of these other units. It just represents a different quantity. In our case, it represents 6.02 times 10 to the 23rd. So how did they come up with the mole, and how do we use it? The person's last name that came up with the concept of the mole was Avogadro. So we refer to that number, 6.02 times 10 to the 23rd, as Avogadro's number. So let's take 12 grams of carbon. Remember, that is the atomic mass of carbon. If I take 12 grams of carbon and I count the number of atoms in that 12 grams, I get Avogadro's number, 6.02 times 10 to the 23rd atoms of carbon. That's what we call 1 mole of carbon. So imagine if I took this carbon and I doubled it. It would weigh 24 grams. It would contain twice as many atoms of carbon and would now be considered 2 moles of carbon. You could do this with any element on the periodic table, and the only thing that would change would be the grams. For example, oxygen would weigh 16 grams if it had 1 mole, and 32 grams if it had 2 moles. But the number of atoms of oxygen compared to those of carbon would be the same. Here's a tricky part. Now keep in mind, we got to keep an eye on these units. 1 molecule of water contains 2 atoms of hydrogen. It's H2O. Which means if I had a dozen molecules of water, wouldn't that contain 2 dozen hydrogen atoms? Notice it's 1 dozen molecules, 2 dozen hydrogen atoms. So what if I had a mole of water? Well, 1 mole of water will contain 2 moles of hydrogen atoms. Notice the sentences are identical except for I've replaced the word dozen with the word mole. A dozen means 12, and a mole means 6.02 times 10 to the 23rd. So essentially, a mole means 6.02 times 10 to the 23rd of anything. It could be books, pennies, atoms, molecules, formula units, ions. It could be anything. So we consider it to be 1 mole equals 6.02 times 10 to the 23rd particles. So, what kinds of particles do we deal with commonly in chemistry? Here they are in this table here. A particle could be an atom, if it's just 1 element on the periodic table, like carbon, nitrogen, oxygen. It could be a molecule, if it's a compound, made up only of nonmetals or covalently bonded. It could also be a formula unit if it's a salt, such as sodium chloride or magnesium oxide. Or it could be an ion if it's a charged atom, such as calcium 2+ or oxygen 2-. So when I say particles, you have to know that I'm talking about either atoms, molecules, formula units, or ions. So let's do some math with these mole calculations. And in order to do this math, you're going to have to do dimensional analysis. If you're having trouble with dimensional analysis, please go visit my other podcast that covers that subject. So let's talk about this question. It says, how many atoms of carbon are in 3.45 moles? Well, I notice I have 3.45 moles of carbon, and I need to know how many atoms there are. Well, atoms is a type of particle. So I'm going to start it off with 3.45 moles of carbon, and I put it over 1 because it only has 1 unit. And now I use dimensional analysis to cancel out those moles and get us into our particles. So I write my conversion factor that you see in the bottom right. 6.02 times 10 to the 23rd atoms of carbon are in 1 mole of carbon. Notice I used atoms and not particles because I'm specifically talking about these atoms of carbon. The moles will cancel out, and we are going to multiply the top and divide by the bottom, and we will get 2.08 times 10 to the 24th atoms of carbon. So 3.45 moles of carbon will contain that many atoms of carbon. Let's work the other way. If I had 2.28 times 10 to the 22nd formula units of sodium chloride, how many moles does that represent? So let's think. Formula units is a type of particle, and NaCl is a salt, so it makes sense. So I'm going to write that out. Notice I abbreviated formula units with Fu. So I put 2.28 times 10 to the 22nd Fu over 1, and now I have to convert it into moles. So you'll notice that the particles are Fu, so I'm going to put those on bottom. There are 6.02 times 10 to the 23rd formula units per mole of sodium chloride. So when we take this, we're going to divide 2.28 times 10 to the 22nd divided by 6.02 times 10 to the 23rd, and that represents 0.0379 moles of sodium chloride.